These are notes for Calculus AB on matrices. This is Objective 4, which is on determinants of a square matrix. So we'll look at how to find the determinant of a 2x2, 3x3, and 4x4 square matrix. And I've written up here at the top the notation that we use for determinants when we're working with matrices. So we might write DET in front, or we might use what looks like absolute value symbols. So to start with a 2x2 matrix, this one will be the easiest. And to find the determinant of a 2x2 square matrix, we can write this as the determinant of A, B, C, D, using those absolute value symbols. And then all we do here is multiply A with D, and then subtract and multiply C and B together. And that right there will give us a little formula, if you will, for a 2x2 square matrix. So I have an example for us here. So for a 2x2 matrix A, the determinant of matrix A, we're going to multiply -1 with -4, and then subtract and multiply 7 with 3. And so 4 minus 21 is -17. And that is the determinant of that matrix. So determinants will tell us some things about other matrices, other things we can do with this matrix. It's a part of some formulas as well. And so we get into the uses of the determinant in other objectives, but today we're just concentrating on how to find the determinant. So next will be our 3x3. Which we can actually find the determinant in a very similar way to the 2x2, but it takes a little bit of practice. So the first thing I want to do is I'm going to rewrite matrix B twice. So to find the determinant of matrix B, I'm going to take my matrix here, and I'm going to make a little dashed line and repeat the matrix. Oh, that should just be a line there. So anyway, in finding the determinant here, what we want to do is start in the same way we did with the 2x2. We're going to go top to bottom on this main diagonal. So you'll see 1 times -1 times 1. So we want to do this first. This is going to give us a product of -1. And then we're going to do the one next to it, 2 times 3 times 4. So that's 24. And the one next to it, 4 times 2 times 0, which is 0. So that's going down, just like we did down with A times D here. So after that, these are all the downsides. We want to subtract and do the opposite diagonals here. So we'll put a minus sign, and now we'll come back up. So we'll start here in this bottom corner, 4 times -1 times 4, -16. The next diagonal is 0 times 3 times 1, which is 0. And the last one, 1 times 2 times 2, which is just 4. And so all the numbers end up getting used. And this is just a nice way of using finding the determinant of a 3x3 without doing something else more drastic just yet. So we'll simplify our values here. We have 23 minus -12. And so we add 23 and 12 to get 35. And that's the determinant here. So in order to do a 4x4, we can't continue on with this pattern. We instead have to use another method, and that's by using something called a cofactor matrix. So a cofactor matrix can be of any size. You want to start with a positive sign in the first entry, And then from there, we alternate signs as we go across a row or down a column. So plus, minus, until we get to the end of the matrix itself. So in order to do the determinant of a 4x4 matrix, like this one I have here, matrix C, we're going to start by choosing any row or column. You start by choosing any row or column. But the best way to choose a row or column is to find one with the most zeros. So a little hint, look for zeros. And so I have row 2 that has 2 zeros in it. So I'm going to use row 2. And what I do is I'm going to multiply row 2 by my cofactor matrix. So notice if I were to go to row 2 here of the cofactor matrix, the first entry is going to get multiplied by a negative. So I'm going to multiply -2 by a negative, and that'll make it a +2. 0 would get multiplied by a plus. 0 is still 0. 6 would get multiplied by a negative, so that would make it a -6. And then the next sign would be plus. So 0 is multiplied by a positive. 0 is still 0. Okay. These new numbers, +2, 0, -6, and 0, are going to become my scalar multiples. So I'm going to have +2, 0, -6, and 0. And we won't worry about the zeros. Whenever I multiply anything by 0, they just zero out. So we'll see those drop out. So here's the next thing that we have to do. We have to write down a leftover matrix that we have. So we take 2, which is in row 2, and it's also in column 1. And we're going to cover up row 2 and column 1. So my pens are a little bit wide for this, but if I cover up column 1, and if I cover up these 3 entries of row 2, you're left with, above it, 6, -5, 4. So I'm going to write those down. 6, -5, 4. Okay, so I'm still covering up, but 2 here was in column 1, row 2. So you want to cover up column 1 and row 2. Underneath what I'm covering up, those remaining 2 rows with those 3 entries each, we're going to write those down. So we have 1, 2, 2. And we have 3, -1, -1. So we are going to have to multiply 2 with the determinant of this 3x3 matrix. Then we add it to 0 times the determinant of the next 3x3 matrix, which 0 times the determinant, 0 times anything, will just be 0. So we won't worry about this one here. And for the same reason, we won't worry about this one here. But we will need to write down the 3x3 matrix here. Okay, so let's take a look at 6, which was in row 2. So again, we're going to cover up row 2, and it's in column 3. So you want to cover up column 3 and row 2. So you can see what we're left with. 3, 6, 4. Okay, underneath column 2, underneath row 2, and covering up column 3, we have 1, 1, 2. And at the bottom, 0, 3, -1. So now you just have to find the determinant of these 2 3x3s and then multiply them by these numbers. Okay, so I'm going to keep this 2 here, give myself some brackets to work with, and inside here I'm going to put the determinant for this 3x3. So I showed you how to do the 3x3 in the last example, and we had to rewrite it. So we're going to practice how could I more quickly do the 3x3 without rewriting it. So let's take a look at the pattern here. We did 1, -1, 1. So we went right down that main diagonal here, top to bottom. We then did 2, 3, 4. So that 2, 3, and the 4 at the bottom here is the 4 from that first column. So we did 2 times 3 times this 4 over here. And last we did the 4 at the top here with 2 times 0. And that 2 times 0 came from here. So we did the main diagonal. We did 2 times 3 times this 4. And then 4 with 2 and 0. So you see how all the values get used again. Okay? And you always want a group of 3. 3 on the diagonal, 2 with 1 on the bottom, and then the 1 above with the last 2. You do the same thing working your way up. We go on this main diagonal here. We'll do 0 and 3 with 1 at the top. So 2 from one side and 1 number from the other side. And then 1 with 2 times 2. That's the pattern we went in. So we're going to repeat that here and hopefully get used to it without having to rewrite it a lot. But if you're more comfortable with rewriting it like I did the first time with the 3 by 3 and calculating it that way, that's fine. So here we're going to start with 6 times 2 times negative 1. Go this way. All right, so this is going to give us a product of negative 12. We then do negative 5 times 2 times 3. So that's negative 10 times 3 is negative 30. And last, 4 times 1 times negative 1 is negative 4. Then we subtract, and we multiply the numbers in the opposite direction. 3 times 2 times 4 is 24. Negative 1 times 2 times 6 is negative 12. Negative 1 times 1 times negative 5 is 5. Okay, and we'll repeat that over here with the next one. So we bring down our minus 6 times, we'll fill this one in here. So we'll start at the top. 3 times 1 times negative 1 is negative 3. 6 times 2 times 0 is 0. And 4 with 1 times 3 is 12. So we did this diagonal here. 6 times 2 times 0. And then the last 3 numbers, 4 with 1 and 3. We'll subtract and come back up. 0 times 1 times 4 is 0. 3 times 2 times 3 is 18. And negative 1 times 1 times 6 is negative 6. And then from here, we'll just simplify. All right, so we have negative 42 minus 4 is negative 46. Minus 12 and 5 is 17. Over here, 9 minus 12 negative 63 minus 6 times negative 3. We have negative 126 plus 18 is negative 108. And I think you only have one of these 4x4s to try on the homework assignment. And only a few problems altogether on this one. All right, and that is how you do a 4x4, and it does take practice. And I just want to remind you that whatever row or column that you chose, even if it doesn't have zeros, but that just will make even less work for you if you choose those rows and columns. As you're writing those values down, remember to cover up the row and column and to just use the numbers that are left over. You want to keep them in the same order. They just condense down to make that matrix. All right. That is the end of the notes for Objective 4.